All right, today we're diving into something that you use literally every day, probably without even thinking about it. OAuth 2.0. Think of it as the invisible security guard of the internet, the protocol that lets all your favorite apps talk to each other securely, without you ever having to hand over your most important passwords. So, let's pull back the curtain and see how it all really works.
You've seen this button a million times, right? You find a cool new photo editing app, you click Login with Google, and bam, you're in. You never typed your Google password into that app, but somehow it can now see your photos. How in the world does that happen? Well, that little bit of secure magic, that's OAuth 2.0 in action.
To really get why OAuth is such a game changer, let's use a simple analogy. See, in the bad old days, giving an app access to your account was like handing over the master key to your entire house. You gave it your username and your password, and it could do anything you could do forever. It was a security nightmare. OAuth flips that completely. It's like giving a valet a special key for your car. That key only works on the car, it's only valid for a little while, and it definitely can't open your front door. It's limited, it's specific, and it's temporary.
So here's the official definition. And the two most important words on this slide are delegated authorization. All that really means is that you, the owner of the data, are delegating permission. You're the boss. You're telling Google, hey, this photo app, yeah, they're cool. It's fine for them to see my pictures, but only my pictures. Nothing else. You're in charge.
Okay, so to see how this all plays out, we first need to meet the cast of characters. Every single time you use OAuth, there are 4 key players on the stage, all part of a carefully choreographed security dance.
First up, and without a doubt the most important player, is the resource owner. And guess what? That's you. You own the photos, you own the emails, the contacts, all that digital stuff is yours. In our valet analogy, you're the car owner. You're the one who decides who gets the keys.
Next, we have the client. This is that shiny new photo editing app that's asking for your permission. It's the third-party service that wants to do something useful for you with your data. So in our story, this is the valet service, politely asking for the keys to your car.
Our third player is the authorization server. This is the big, trusted service where your account lives. Think Google, Microsoft, Facebook, you name it. Its job is to know who you are, ask for your permission, and then securely issue those valet keys, which in the real world are called access tokens. You can think of it as the official dealership that verifies you're the real owner before it even thinks about handing out a key.
And finally, we have the resource server. This is the service that's actually guarding your protected data, like the Google Photo servers or the Gmail API. In our analogy, this is the car itself. It's not going to unlock its doors or start its engine for just any key. It only trusts the official valet keys issued by that dealership we just talked about. So now that we've met all our players, let's watch the play unfold. We're going to walk through the most common and, more importantly, the most secure way this happens, a process called the authorization code flow. This is the actual valet key handoff.
Okay, let's break this down. It all starts when the app, our valet, asks you for permission. You're then immediately whisked away to Google's website, the dealership, where you log in securely. There, Google shows you a screen that says, this app wants to view your photos, and you click Allow. Now here's the really clever part. Google doesn't just hand the final key to the app. Nope. First, it gives the app a temporary, one-time use authorization code. The app then takes that code and, in the background, over a secure, secret channel, it exchanges it with Google. Only after Google verifies that code is legit does it finally hand over the real prize, the short-lived access token.
This whole multi-step dance is precisely what makes the process so secure. And for modern apps, it's almost always paired with another layer of security called PKCE. You don't need to know the details, but it basically creates a secret handshake between the app and the server, which makes sure that even if an attacker somehow stole that temporary code, it would be totally useless to them. This combination, it's the absolute gold standard for app security today.
Now, we've been using this term key or token a lot. But just like a real keychain might have a few different keys for different doors, in the world of OAuth, there are a few different types of tokens, and each one has a very specific job.
So there are really 3 main types you should know about. First is the access token. This is the actual valet key we've been talking about. It's what the app presents to get your photos, and for security, it expires very quickly. Then you have the refresh token. Think of this like a claim ticket. When the valet key expires, the app can use this long-lived token to get a new one, without having to bother you to log in all over again. And finally, there's something called an ID token. This actually comes from a layer built on top of OAuth called OpenID Connect. This one is different. It's less of a key and more like an ID card. It proves who you are. And that brings us to an absolutely crucial distinction, one the source material really hammers home. OAuth itself is only about authorization. That's what an app is allowed to do. It provides the valet key. It does not, on its own, handle authentication, which is all about who you are. That's the job of that other layer I mentioned, OpenID Connect, which provides the ID card.
So after all that, what are the big takeaways? Why do we go through this seemingly complicated process? Well, it's because it builds a fundamentally more secure and private web for every single one of us.
The benefits here are just huge. First and foremost, your master password is never ever shared with that third-party app, period. You also get to grant super specific, granular permissions. Not just access my whole account, but something as small as read-only access to my contacts. You are always in control. You can pop in your Google account settings anytime and revoke an app's access, basically taking back that valet key instantly. And maybe most importantly, if one app gets hacked and its key is stolen, the damage is contained. That stolen key can't be used to take over your entire digital life.
Of course, the world of security is always evolving. What was secure yesterday might not be today. So what are the modern rules of the road for using OAuth safely and effectively, both today and into the future? For anyone out there building software, these are basically the non-negotiables now. You always use that secure authorization code flow with PKC. You only ask for the permissions you absolutely need, nothing more. This is called the principle of least privilege. You should use advanced features like sender-constrained tokens, which basically lock a token to a specific app so it's useless if stolen. And you always rotate your refresh tokens after each use and are super strict about validating where you send users after they log in.
And this chart right here is exactly why those best practices are so critical. Older ways of doing things, like the implicit flow, which used to put the access token right in your browser's address bar, yikes, are now considered way too risky. And the really old password flow, where an app just flat out asks for your username and password, that's a massive security no-no. As you can see, the security gap between the modern, low-risk approach and these old, deprecated methods is absolutely enormous.
So OAuth gives us this fantastic, robust system for delegating access, for handing out those valet keys in a really secure way. We've totally solved the problem of what an app is allowed to do, but this leaves us with one final and really important question. How does that app truly know who you are? Your access is secure for sure, but is your identity truly verified? And that, well, that's a whole other story.